Hello viewers, welcome to my YouTube channel CASE-3 Hub. I am Professor Vinod Kumar from the Department of Civil Engineering. In today's video, we are going to see Principal Stresses and Strains Part 3 and 4, that is Case 3 and 4. Case 1 and 2 have already been published. Those who haven't watched it, kindly watch it. I have given the link in the description. In this analytical method, we are going to see about Case 3. Case 1 was normal stresses acting along one direction, and Case 2 was normal direction acting along two mutually perpendicular directions. This Case 3 is a member subjected to simple shear stress. Here the normal stress is not acting. This is only shear stress. Here in this diagram you can see the shear stress tau acting on all the four sides, AB, BC, CD and DA. And FC is your oblique plane, where theta is your angle of inclination made by that oblique plane with the normal BC, and tau is your shear stress across BC and AD. For this triangular portion we are taking this BC and BF portion. From the oblique plane FC there is a normal force Pn and a tangential force Pt. Now you can see in this diagram a downward force Q1, that is a shear force Q1 is acting along the face BC. Okay, this shear force, if we convert it into stress formula, it is shear stress into area of that BC. We know that the shear stress is tau, denoted by tau, and the area of BC is BC into 1. 1 is your unit thickness. So it becomes tau into BC, that is Q1 is equal to tau into BC. And there is another force Q2 acting along the face FB. So we get shear stress into area of FB. So shear stress is tau, area of FB is FB into 1. 1 is your unit thickness, that is equal to tau into FB. So your Q2 becomes tau into FB. As already said, Pn is equal to your normal force on FC and Pt is your tangential force on FC. FC is your oblique plane. Now this Q1 is resolved into Q1 sin theta and Q1 cos theta along FC and normal to FC, and Q2 is resolved into Q2 sin theta and Q2 cos theta along FC and normal to FC. Normal refers to perpendicular. Okay, so this total normal force Pn becomes, at that place for the first diagram now you can see on the top, that becomes Q1 sin theta plus Q2 cos theta. I will explain you how it is. This normal force Pn is perpendicular to the face FC, that is the oblique plane. So these resolved forces perpendicular to the oblique plane, there are two resolved forces, one due to Q1 and another due to Q2. So due to Q1, that is Q1 sin theta, and due to Q2, that is Q2 cos theta. These two are in the same direction, so we are using plus. Okay, so what happens? Pn is equal to Q1 sin theta plus Q2 cos theta. So the total tangential force Pt is equal to this Q2 sin theta minus Q1 cos theta, because these two resolved forces are in opposite direction, so we are taking minus. In the next step we will be substituting for Q1 and Q2 here in these two equations from the values of this Q1 and Q2. So here this total normal force Pn is equal to Q1 sin theta plus Q2 cos theta. We have done in the previous step. Now here substituting for value of Q1 and Q2 here, it becomes tau into BC into sin theta plus tau into FB into cos theta, with the values of Q1 and Q2 here, which is already found in the previous step. And your total tangential force Pt becomes Q2 sin theta minus Q1 cos theta. So substitute for Q2 from here, that is tau into FB into sin theta minus tau into BC into cos theta. Now what happens to the normal stress sigma? Normal stress sigma n is equal to normal force acting along FC divided by the area of section FC, that is the formula. So the normal force acting along FC is your Pn, this first one, divided by area of section FC is FC into 1. So substitute this Pn equation here, it becomes tau into BC into sin theta plus tau into FB into cos theta, the whole divided by FC. Now again we are splitting these two, this equation into two, that is tau into BC by FC sin theta plus tau into FB by FC cos theta. So from the triangle BFC, sin theta is equal to opposite by hypotenuse, that is your BF by FC, and cos theta is your adjacent by hypotenuse, that is BC by FC. So using these two equations, this equation BC by FC becomes cos theta and your FB by FC becomes sin theta. So the equation becomes like this, that is equal to tau into cos theta into sin theta plus tau into sin theta into cos theta. So here this cos theta sin theta is common, so we are taking tau to the other side, we will get 2 times cos theta sin theta. So we are getting 2 times tau into cos theta into sin theta. This 2 cos theta sin theta is sin 2 theta, that is trigonometric formula. So what happens to this? It becomes tau into sin 2 theta. Okay, so your normal stress sigma n is equal to tau into sin 2 theta. Let us keep this equation as 1. Similarly, what happens to the tangential stress? Sigma t is your tangential stress along FC, that is equal to tangential force along FC divided by the area. So what happens? It becomes PT divided by FC into 1. We know the value of PT as tau into FB into sin theta minus tau into BC into cos theta. This is calculated in the previous step. The whole divided by FC. Again we are splitting it, so it becomes tau into FB by FC sin theta minus tau into BC by FC cos theta. Similarly, from the triangle BFC, we know that sin theta is equal to BF by FC and cos theta is equal to BC by FC. So substitute it here. So it becomes tau into sin theta minus tau into cos theta. So again simplifying, we get tau into sin square theta minus tau into cos square theta. So here tau is common and there is a minus symbol. So we are taking minus tau outside, because in order to convert the trigonometric formula, we are changing this. So it becomes minus tau into cos square theta minus sin square theta. We are changing because if we change only, we will get this cos 2 theta. That is the trigonometric formula. So the final answer is minus tau into cos 2 theta. This is equation number 2. Remember equation 1, sigma n is your tau into sin 2 theta. Here sigma t is your minus tau into cos 2 theta. Equations 1 and 2. This negative sign indicates sigma t is acting downwards on plane FC. Is that clear? So this is with case 3 of analytical method. Now let us see analytical method case 4. Once again I will recall. Case 1 was stresses acting along one direction. Case 2 was stresses acting along two directions. Case 3 was shear stress acting on all the four sides. And this case 4 is a combination of case 2 and case 3. That is, a member subjected to like direct stresses in two mutually perpendicular directions accompanied by a simple shear stress. This simple shear stress is your case 3 and case 2 was stresses along two directions. So this case 4, in order to easily remember, this is case 2 plus case 3. So we saw in case 2 sigma n was sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta. And in case 3 we saw sigma n is equal to tau sin 2 theta. Here I have mentioned in bold letters in order to differentiate this. So the combination of the 2 and 3 finally gives you sigma n is equal to sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta plus tau sin 2 theta. Similarly, for sigma t we found case 2 was sigma 1 minus sigma 2 by 2 into sin 2 theta and case 3 was minus tau cos 2 theta. So adding those two we get this equation. And in case 4, the position of principal plane we can calculate with this formula, tan 2 theta is equal to 2 tau by sigma 1 minus sigma 2. Okay, is that clear? Now what are the major principal stress and minor principal stress? Let us see it. This major principal stress is sigma n is equal to sigma 1 plus sigma 2 by 2 plus, this plus you should keep it in your mind, square root of sigma 1 minus sigma 2 by 2 the whole square plus tau square. Okay, this is the formula for calculating major principal stress. And for minor principal stress, sigma n is equal to sigma 1 plus sigma 2 by 2 minus square root of sigma 1 minus sigma 2 the whole square by 2 plus tau square. The same formula, the only change is for major principal stress we use plus and for minor principal stress we use minus. Now what is your maximum shear stress? That is sigma t max. In case 2 we found it as sigma 1 minus sigma 2 by 2. Here This is a combination of 2 and 3, so it becomes half of square root of sigma 1 minus sigma 2 the whole square plus 4 tau square. Okay, so these are the formulas which we will be using for calculating the numerical problems. So in today's video, this is it. We will work out numerical problems in the next video, which is a combination of all the 4 cases. Okay viewers, thank you so much for your kind patience. If you like my video, kindly subscribe and press the bell button for getting updates. Let's meet in the next video. Thank you. Bye.